Good morning, Doctor. Now my team is going to present the draft database project. My team going for the grocery stock management system, and now I'm going to introduce my teammates. My teammates consist of 3 members, which are Ong Qiao Hui, me myself, Wei Ming, and Teoh. We are from the group BITS S1G1, and which are the branch from the FTMK. Now let's start with the problem statements. As a grocer, there are a lot of problems that are going to face. The first problem is the sudden realization of out-of-stock condition, which would often be found if the grocer didn't notice their product quantity, or they just realize it when the customer made their order, and after they checked the product quantity, they just found out that they are run out of the product and couldn't provide the customer the product itself. The next problem is the inaccurate recording of data or information. The next problem is time consumption and waste of human workload by manual entering of data. Next is hard to keep track of purchase or past records. The next problem is the record is vulnerable to inevitable human error, maybe caused by laziness, maybe caused by tiredness of the workers, and so on. Now we are going to talk about the objective of why we want to develop the grocery stock management system. The first objective is to ensure the continuous supply of stock and prevent overstock or understock. Next is to maintain the record of the purchasing or selling. We also want to maintain the stock details as we are able the stock manager to insert the details for each product. We also want to create a user-friendly system and also a secure inventory database system. With the grocery stock management system, we hope that it can help us to reduce the manpower and error that we have found from the product or from the record itself. For the scope of our grocery stock management system, we are including changing of the inventory system, the implementation of the stock management system, providing better user experience to the workers and staff, reduce human workload, and also reduce human error. Now I'm going to talk about our system user. There are 3 in particular, which are stock manager, salesperson, and also our customer. For the stock manager, he can key in the product or stock details. He is able to apply changes to the product details, which he can change when he found there's an error or there's any misentered information. He is able to take care of the stock quantity and make purchases to prevent the understock. He is also able to keep track of past purchases or product records. He is also able to inform the supplier regarding the purchase product error and make a refund or exchange for a dominant product. For our salesperson, they can process the customer's order by tracking the stock information to see whether is this the customer orders that they want, and also to check the quantity of the stock. For our customer, they can get product details in a short time by keying the product keywords, and also they can make order in a short time through the salesperson. Now for the modules. For our grocery stock management system, there are a couple of modules, and I'm going to explain their functions one by one. Now let's start with the product modules. There are 3 product modules that we got, which are product stock module, product management module, product type module. And why I list them under product module and explain them all at once, because they got almost the same function, which they can add new records, they can edit their existing records, they can delete their existing records, they can display their records in details, and they can listing their existing records, and last but not least, record past purchases from suppliers. Now for the salesperson module. The salesperson module can receive customers' requirement and process customers' order. It can also work on available products and daily check the stock availability. For the stock manager module, it can key in product or stock details such as product type, quantity, brand, and price. They also can check in on product quantity to prevent stock out problems. The stock manager takes care of stock purchasing and stock defects checking to check whether the product has any errors, and if there's any errors, the stock manager could ask for the supplier for any refund or exchange of products. Now for the supplier modules. We can add new records for the suppliers, such as the new suppliers, and edit and update existing records of suppliers, delete existing records of supplier, display the details of the suppliers, and also listing all the existing suppliers, their names, their ID, their mobile, and so on. Now for the customer module. New records of the customer names can be added. Records of customer can be edited and recorded. The existing record of customer can be deleted, and also the customer's details can be listed. Last but not least, here comes our order module, which we can add the customer name and their order product ID, and also the customer's ordered ID quantity. That's all from me, and now I'm going to pass to the next presenter, Ong Qiao Hui. Thank you.
Hi, my name is Ong Qiao Hui from BITP. I'm going to present the part of project requirement. Our system will allow store manager to key in the data of product type, variety, quantity, brand, and price, and description into the system. All the data is an automated manner where the customer and salesperson can track any information if required. There are sections created according to the item type that assists the customer or salesperson to look for the item precisely in a shorter time. The system will show the detail of the product or item once the customer or salesperson key in the related keyword. The system can add and delete the data type of the product, and it also can update the item details such as maintain the quantity record and update the price. The system can also store the history of purchased product from supplier so that the store manager can track the history of purchased product. The next is justification. First is simplified inventory management. Our system can make the process of managing the store a whole lot easier, time-saving, and sanity. It can also avoid human error by automating the key business processes. The second is avoidance of store out and excess store. Help the store manager in checking store quantity and maintain the right balance to avoid store out and excess store. The third is providing better user experience. System can allow the customer to track the product or item information, price, and location in grocery. It can decrease the time spent in searching for the product for customer. The last is reduce the workload of employees. It can reduce stress and improve productivity and profitability, elevate employees' mood. It can do a lot to ease the frustration of both management and manual laborers. And the next part is design. There have 3 designs included in our system. The first is architecture design. Architecture design is helping to design, develop, implement, and maintain the database management system. It can allow dividing the database system into individual components that can be independently modified, replaced, ordered, and changed. It also helps to understand the component of the database more easier. The second is logical design. Logical design serves as the structure to map requirements. It can provide a mechanism for mapping dependencies between components, act as an abstraction layer between the design factor and the specific solution. It also allows creating the framework of the design without disrupted by the product-specific detail. Here is the entity relationship diagram for the logical design. We can show that customer table is related with the order because the customer will place the order and the salesperson will get the order from the order table and the order will deliver to the product table. If the product have any error, it will detect by store manager and the supplier will supply the product once the store manager purchase the product. The next design is physical design. Features in physical design is specification or table and column. Foreign keys are used to identify relationship between tables. Denormalization may occur based on user requirements. Physical consideration may cause the physical data model to be quite different from the logical data model. The physical data model will be different for RDBMS, which is the Relation Database Management System. For example, data type for a column may be different between Oracle and DB2 compiler. And here is the entity relationship diagram for physical design. The difference between the physical design and logical design is physical design, they have the data type in the diagram. In conclusion, there have a lot of benefit in our system. For example, our system is simplified inventory management, avoidance of store out and access store, providing better users experience and reduce the workload of employees. And our system can also store the data of product type, variety, quantity, brand, price, and description into the system. It also helps the customer to track the product that they need by keying the related keywords. And our system is friendly to use so that the customer can be easier to use and track the product in a short time. That's all for me. Thank you.
Good morning, I'm Teoh. I'm going to present the SQL command for our project. We have 8 tables. Let's see the SQL command for creating the table customer. Create table customer ID varchar bracket 10, column name of the table, and varchar bracket 10 is the data type of the column. So we have customer name, varchar bracket 35, customer mobile, varchar 11, and we have primary key bracket customer ID, means we set the customer ID as the primary key, so it is not null and must be unique. And then we insert the value into the table. The first value is the customer ID, the second value is customer name, and the third value is customer mobile. Single quote are used to indicate the beginning and the ending of the string in SQL command. Let's see the output of the SQL command. Okay, you can see here we have 6 rows. We have customer ID, customer name, customer mobile as the column name, and all the data are inserted successfully into the table. Next, we look at the describe customer. We can see the data type, the length, and primary key nullable. All is matched with our SQL command. Next is salesperson table. Create table salesperson ID, char 6, salesperson name, char 35, salesperson mobile, char 11, and primary key, salesperson ID. The primary key is the salesperson ID. It is not null and it must be unique. After that, we insert the value into the salesperson table. We have total of 5 rows of data. Select all from salesperson and run. We can see the data, the 5 rows of data is inserted successfully and the column name is correctly created. Let's see the describe salesperson. So we can see the salesperson table, the data type, the length, the primary key and the null table is matched with our SQL command. Let's see the third table, which is stock manager. We click table stock manager, manager ID char4, manager name varchar 35, manager mobile varchar 11, primary key is the manager ID. And then we insert the value into the stock manager table. We have 4 rows of data. Let's see the output. So the SQL command is work. Let's see the describe stock manager table. We have stock manager as the name of the table, column, and data type length, primary key, nullable is matched with our command. Next, let's look at the supplier table commands. We click table supplier ID char5, supplier name varchar 35, supplier mobile varchar 11, and primary key is the supplier ID. And then we insert 4 rows of data into the supplier table. All of the value are single quoted. Let's look at the output. We have 4 rows of data which are same as the data in the command. Let's see the describe supplier. The table name is correct, the column name is correct, data type length, primary key and nullable is matched with our command. Let's see the stock manager supplier table. Click table stock manager supplier, supply index varchar4, manager ID char4, supplier ID char5, primary key supply index. Primary key is supply index and manager ID refers to the stock manager table. Manager ID is referred to the manager ID in the stock manager, and supplier ID refer to the supplier ID in the supplier table, and also R as the foreign key. And then we look at the insert data into the stock manager supplier. We have 4 rows of data. Let's see the output. We select all from stock manager supplier. We can see the 4 rows of data is inserted. Let's see the constraint, the data type of the table. Data type, the length, the primary key, nullable is matched with our command. So let's see the product table. Click table product. Product ID varchar 8. Product name varchar 30. Product quantity int, which is integer. Product brand varchar 20. Price numeric 2. 8 is the length of the number and 2 is the decimal place. Product description varchar 150. Supply index varchar 4. Product ID is the primary key. And supply index refer to the supply index in stock manager supplier table and act as a foreign key. There are 7 rows of the data. So let's see the output of the product table. Here are 7 rows of the data which is same as the data in the command. Let's see the describe product. So the data type, length, primary key, nullable is correct. Here is the SQL command for the customer order table. Click table customer order. Order ID varchar 9. Salesperson ID varchar 6. Customer ID varchar 10. order quantity, int integer, product ID, bar chart egg. We set the order ID as the primary key and the salesperson ID refer to salesperson ID in salesperson table, customer ID refer to customer ID in customer table, product ID refer to product ID in product table. All these three are as foreign key. We insert 6 rows of data into the customer order table. The integer is not single quoted because the data is fully integer. Let's see the output of the table. There are 6 rows of data and 5 columns. The name correctly. Then let's see the describe customer order table. So the data type length, primary key, and nullable is matched with our command. Last is error table, create table error, manage ID, manager ID, char for, product ID, bar chart egg, error description, bar chart 150. So here the manager ID and the product ID is the primary key and also composite key. Manager ID refer to manager ID in stock manager table and product ID refer to product ID in product table. And then we insert 4 rows of data into the error table. Let's see the output. We have 4 rows of data, same as our command. And let's see describe error table. Manager ID and product ID is primary key and not nullable, and the data type and length is correct for all of these 3 columns. That's all, thank you.